Assalamualaikum and greetings to the panel members. My name is Muhamad Mustaqim and I will be presenting my project Sarjana Muda titled Taguchi Base Quality and Performance Modeling of 3D Printed Thin Wall Part. First of all, I will explain briefly about the content, that is the background of the study. Next is problem statement, then objective, continue with literature review. After that is methodology, and then result and discussion, and lastly is conclusion and future work. The first content is background study. Additive manufacturing is very widely used to make any product or prototype, and each parameter used in additive manufacturing must correspond to what is to be achieved. This study focuses on quality and performance on thin wall models made from additive manufacturing and use Taguchi method as optimization. Now, for the problem statement, 3D printing is very difficult to fabricate when involving thin wall models because incorrect use of parameters can be the reason for thin wall models to be low quality, and the strength of a thin wall model will be easily broken when printing using incorrect parameters. The objective to be achieved in this study is to optimize thin wall parts using the Taguchi method, as well as to validate that the method of optimizing with the parameters to be used can be applied to the production of thin wall products. In the literature review, many researchers have used the Taguchi method to be optimized on additive manufacturing, as can be seen on the slides. On the methodology, this is a flowchart from beginning to end throughout the course of this research. Described briefly, the parameters used are printing speed, layer thickness, and extrusion temperature. Layer thickness means how high the layer after layer will be printed, and the extrusion temperature means the temperature at which it is melted before being extracted out of the 3D printing nozzle. After parameters has been set, the design of experiment will generate L9 orthogonal arrays, and all the data is used to print the study model. In the next step will be described in the results. This is the model design that will be used to conduct the research. And this is the design of experiment DOE table with 9 runs were used after 3 parameters are taken and use 3 levels, namely low, medium, and high. This is a model design that was printed using Ender V3, and 9 models were printed to measure the response value. Continue on the result of the study. After printing the model design shown previously, each experimental run from 1 to 9 obtained different response values. The response value with the outside diameter of the shape model. This is because of this parameter plays an important role in obtaining dimensional accuracy. Next, after entering the response data in the Taguchi analysis, the signal-to-noise ratio graph as well as the means graph will be obtained. On the signal-to-noise ratio graph, the rounded points are the appropriate values for printing thin wall parts, but this is just a theory on a graph. To confirm that the graph is correct or not, the regression method will be used. The regression method is used because we will generate an equation, and this equation will be used to compute each of the experiment runs as a validation. Predictor values in the table are the result of calculation of each parameter using the regression equation on the previous slide. Next, after obtaining the predicted value, an error calculation will be performed on each experiment run. To validate the experiment run, the error calculation is shown on the slide. Now, this is the table shows the predicted values as well as their error at each experiment runs. As a conclusion, N2 validation were done theoretically and calculation. Experiment number 7 was the best, the production of a thin wall model because of the least error of all the other experiment runs and following with the signal-to-noise ratio graph. For the future work, the experiment model will be experiment on the porosity of the model. Thank you and Assalamu alaikum.